Yes? Can? Let's take a look at the questions already. I'm going to go start already. You look at it? I'm glad you realize. Find some similarity. Okay, now let's look at this. We have the story here. Jensen paid $945 for a table and 4 chairs. So there's a table, there's a chair. The price of the chair was 2/7 of the price of the table. It's a fraction question. How much did he pay for one chair? Okay, it's a fraction question. Look what I'm going to do. I'm going to do ratio here. So we have the chair and the table. What's the ratio of the table, chair to table? Very good, 2:7. Right? So this is the chair, this is the table. Correct? This one chair is 2 units. One table is 7 units. Right? Okay. If I have a table and 4 chairs, so 4 chairs, how many units? 8 units. 2 times 4, ma? So, and one table, how many units? 7 units. Okay, so altogether, how many units? 15 units. 15 units is $945. Oh, I forgot to say you can use a calculator. Can you take the calculator for this? This is all the questions for paper 2 actually. So what's 1 unit? 63. So a chair is 2 units. So it's 63 times 2, 100 and? Sorry? Okay. Look at this question now. Is it easy, difficult? Manageable, right? Yeah. Do you think drawing the model helps?
Yes.
Okay. When I express it as a ratio, is it helpful too? Yeah, probably yes, right? Okay. We done? That was just barely 5 minutes, you know. Yeah, we solved this question in barely 5 minutes. Yeah. Okay. But does it sound like it's something that is doable now? Very much. I'll move on? Shall we? Can I move on? Okay? Okay. Now, I move on. I'm going to do, really, this is a fraction and ratio. This is a whole number topic actually. This one is a whole number question. It's a question from whole numbers. But I'm going to use ratio to solve, okay? The first one says apple and papaya. And the second one is still apple and papaya. The first one, I'm going to use ratio to express. 6 apple is to 4 papaya. Is this okay? Am I going too fast for you? Six apple is to 4 papaya. That's 11.20. 2 apple is to 1 papaya. That's $3.10. I want to find papaya. I'm going to try to use the idea of changing ratio and equivalent ratio to solve this. To find papaya, I want to try to make something the same. Yeah, so I'm going to try to make apples the same. I have 6 apples here. I'm going to try to make this become 6. What do? Times 3. that will become 6 is to 3. So $3.10 times 3, what do I get? $9.30. Oh, take a look at this. 6 apple to 4 papaya is $11.20. 6 apple to 3 papaya is $9.30. Can I find papaya now? I just take 1120 minus 930. Isn't it? Yes. For all of these questions, they are all for paper 2. So you can use the calculator. But can you see already? I use 4 units here minus 3 units here. So 1 papaya will just be 1120 minus $9.30, and the answer is $1.90. Now look at this now. Is this solvable? Now the truth is I can use an entirely different method to solve this. The whole number method. Yeah. So you choose. You got to know how to choose. If I use the ratio to do this, can you solve? Yeah. Okay. Because I have 4 papaya, 3 papaya here, so I just use 1150 minus 190. Is this okay? Now, move on to the next question now. I'm at this question that, like, more than 3/4 of class couldn't do it. Why? No, I don't want the answer. I want why and how. The truth is, Skylar, during the exam time, more than 3/4 of the class couldn't solve this question. Is it going to be helpful if I just tell you, oh, the answer is 50, full stop? No, not at all. If the question comes out in the exam in the different numbers, there's no number to remember. Now, let's look at this. There are 2 characters here. There's Mr. Tang here, and then there's these. And then there's a sum and difference that I've learned. And look, for the whole time of changing ratio that I've talked about yesterday and the day before, we mentioned about the comparison of age. And about like exchanging money, things like that. And we talk about the difference in their age. So Mr. Tang can change, the knees can change, their sum will definitely change, but the difference in years doesn't change. The difference in their age won't change here. His niece will forever be 30 years younger than him. 1 year later, his niece will still be 30 years younger than him. 10 years later, his niece will still be 30 years younger than him. So, the ratio of Mr. Tang to his niece. You wanted him to be twice as old as his niece. That will mean that is this ratio, isn't it? Correct? So what's the difference between them? How many units is that? Also 1 unit. If I draw the model out, it says here, this will be Mr. Tang and the niece, and how they're supposed to look like in some years' time. In some years' time, they will be 2:1, and the difference is 1 unit. And this is 30. So how old will Mr. Tang be? 60 years old. So 1 unit is 30, 2 units, Mr. Tan will be 60 years old. He is 45 years old now. So, 60 minus 45 in 15 years' time. Now, we have 2 friends in the class who got this correct by 2 different methods. One of them they use, yes, Ryan, what do you use? No, in your exam time. Huh? Actually, that was when you wrote that was not exactly the correct method. But I gave you the better one, yes. Yeah, okay. There are other methods. One of your friends got it by guess and check, listing. He listed a whole year of next age, next year, next age, next age, and got the answer. You know, entirely acceptable. By guess and check, listing, whole numbers, and now I show you ratio. Is it helpful? It's up to you. If you feel that this is still a bit challenging, then actually the easiest method is what your friend did. Listing and guess and check. One by one, try. But it's very tedious. Yeah. Okay, last one. This one is the one that easiest. Then why do I see so many people getting correct? Now, this is the harder question. It is a fraction question. Okay? But we're going to talk about how to use ratio to solve. And I also show you the fraction method. Okay? Now, here, this question shows 3 girls using the same number of beads to make necklaces. Look, we learn changing ratio. Look, we learn changing ratio. And we said that the key to solve changing ratio questions is to find out what didn't change, right? So right at the start, the big clue give you already. Same. This is the biggest clue. This is the biggest clue of all. Now, how is this not the biggest clue? It's sum. What else? At first, that's right, the most important clue is there. This is not the biggest clue because it is at first, that means there's some change going on. You don't know what's the end. That's the hard part. You don't know what's the end. And why is this again very challenging? All their denominator is different. So for those of you who didn't think much, I have a bunch of you just went to do 2/5 plus 3/4 plus 2/3. Anyhow, plus. Obviously, you got 0. Now, let's read it again, using what we have learned from fraction and ratio to solve. Davy used 2/5 of her beads. Davy used 2/5 of her beads. So for Davy is 2/5 of her beads. 2 is used. The denominator 5 is all her bits. Which I can actually express as 2:5. I can actually write here for Devi, used versus all of Devi is 2:5. Now for Esther, Esther is 3/4. She used 3/4 of hers. So 3 is used. The denominator is all Esther's bits. Now, in this case, I can write it as for Esther, used versus all is 3:4. For Farah is used 2/3 of hers. So for Farah is 2/3. 2 is her used, that's the numerator. For the denominator, 3. 3 is all of Farah's bits. If I use ratio to represent, it says Farah used all 2:3. Okay, let's express this in fraction and ratio. Basically, I'm just converting what I read in the word problem into notes at the side. 1 is fraction, 1 is ratio. Now I attempt to solve. The key is here, same. What does it mean by same? They used the same. It means, yes, this whole row, the quantity should be the same. Meaning, all the numerator and in this column of used, they should be the same. Can you suggest a common multiple? 6. Very good. I convert for Devi. What would it be? 6:15. I convert for Esther. It will be 6:8. I convert for Farah. 6:9. Look, I'm now using the key clue of them using the same number of bits. Based on that clue, I turn the numerator or the portion about them supposedly the same as identical. If I use fraction, it will be the same thing. 6:15, 6:8, 6:9. Now, the last part, solve. Jaren said, the next important clue, total of 1040 bits at first. That's the clue. For this clue, here are the units. All of D, all of E, and all of F, Farah. The answer is to find all of Esther at first. So this is the units. Okay, in other words, 15 and 8 and 9. 15 plus 8 plus 9 units. That's 1,440 bits. In the end, how many units am I supposed to find? Huh? The thing is, that's correct. You're supposed to find 8 units. So 15 plus 8 plus 9 is 32. So 1 unit is 45. I'm supposed to find Esther at first. That's 45 times 8. That is? Huh? 360. Okay. On the left, I wrote fraction. On the right, I wrote ratio. I don't know, honestly. If you look at it yourself now, do you think, given the chance to do the term review again, can you score better? Yes. Because these are all the questions that were in there. Yeah? You didn't realize? You realize? How many of you realize? Do you feel like you can, if I give you these questions you can do again, can solve? Okay, so your challenge is next week, you will be given these 4 questions again. But I'll be using different numbers, of course. Okay? Okay, with that you can file this inside your file, the purple color file. I give you right now, I tell you immediately, yeah? So next week, I'm going to give you a mini test. It will be the 4 exact same questions, but different quantity. Okay? Do you feel confident that you can manage? If the answer is no, please go back and revise again. Okay? Now I have last 10 minutes.